In this video, we're going to talk about random variables. When we mean random variables, we're talking about numerical outcomes of a probability experiment, and we usually discuss the random variables and that they're denoted by uppercase letters, meaning like probability of a capital X, or something along those lines. The first type of random variable that we're going to discuss is the discrete random variable. And those are the ones that have the possible values that can be listed. They may be infinite possibilities, but those are the ones that can be listed. Those are the ones that can be counted. In other words, they're not with intervals. Discrete random variables are things like number of CDs, number of people, things along those lines. Continuous random variables are those that can take on any value in an interval, such as height and weight and those types of things, because it can be anything in between there that those can take on. And so that's what we mean by the difference between discrete and continuous. Recall from previous discussions the difference between discrete and continuous. So for example, we want to know which of the following variables are discrete and which are continuous. The number of cheeseburgers a fast food restaurant serves each day. Now, the number of cheeseburgers that a person consumes can be continuous because they can consume only a partial burger. But the number that they serve is actually discrete because a fast food restaurant cannot just serve half of a hamburger. The weight of an automobile. Now, most of the time the weights of automobiles are done in discrete numbers, but that does not mean that it's actually discrete. The weight of an automobile is actually continuous because it can be anything between 14,000 pounds and 14,001 pounds. So it can be in between there. And that's why that's going to be continuous. The amount of rainfall in Seattle during April. This one can be a little bit different. The amount of rainfall can be 2 inches, 3 inches, 4 inches, things like that, but it can also be 2.56 inches, 2.78 inches. Therefore, that's going to make that a continuous random variable. The number of mathematics majors in your school? Well, since we're talking about mathematics majors, and mathematics majors indicate people, that is going to be discrete. Anytime you're talking about people, that is going to be whole numbers that we're discussing. So a probability distribution for a discrete random variable specifies the probability for each possible value. So when we're talking about probability distributions for these, what we're going to do is we're going to set them up as our variable and then the probability of each possible outcome. So if we have the possible outcomes as being 1, 2, and 3, then we're going to set up the probabilities for each of those. So for example, when we're talking about the Baseball World Series, the Baseball World Series is played by the winner of the National League and that of the American League. The first team to win 4 games wins the World Series. In other words, the series will consist of 4 to 7 games, depending on the individual victories. The data shown consists of 40 World Series events. The number of games played in each series is represented by the variable x. Construct the probability distribution of x. So in other words, for this, there were 4 games played in a series, and there's been 8 series that have been won on just 4 games. 5 games, meaning one team won 4 games and the other team won 1, there have been 7 series won this way. 6 games played, so one team won 4 games and the other team won 2 games. There have been 9 series that have won or been played this way. And then gone all the way to the 7 games, there have been 16 series played this way. And we want to make a probability distribution. Well, first we have to get the probabilities for each of these. Remember, to get the probability is the frequency divided by the total frequency. So the probability for 4 is going to be the frequency divided by the total frequency. And when we divide that out, that's going to give us 0.2. Put too many zeros in there. Most of the time, we take probabilities to about 3 decimal places. And that's not a whole number. Let me retry that. It's going to be 0.200. So the probability that 5 games were played is going to be 7 divided by 40, which is going to be 0.175. The probability that 6 games were played is 9 divided by 40, which is going to be 0.225. And the probability that 7 games were played is going to be 16 divided by 40, which is going to be 0.40. Now this still isn't a probability distribution. All we've done is found the probabilities for each possible outcome. For the probability distribution, we're going to set up our x, so all of our possible outcomes, over their individual probabilities. You can turn it vertically or horizontally, it does not matter. So I can have 4 games with the 200 possibility. I can have 5 games with a 0.175, 6 games with a 0.225, or 7 games with a 0.400. So this right here is my probability distribution for the World Series games. Again, I can turn it the other way, and I would just do x and the probability of x. So I would have 4, 5, 6, and 7, and then I would have their probabilities out beside them. Either one of these can be considered a probability distribution. The most common way is the horizontal way. Either one works though. Now, there are a couple of things that we have to note when we're talking about discrete probability distributions. They must satisfy 2 properties. Remember that all probabilities must be between 0 and 1. So that means that all of our probabilities for each individual probability in our distribution is between 0 and 1. Cannot be negative, cannot be greater than 1. The other thing to remember is that the sum of the probabilities within our distribution must equal 1. So the sum of the probabilities must equal 1. So that it has to satisfy both of these in order to be a probability distribution. So let's look at some probability distributions and determine whether they are or are not probability distributions. So this first one, when we're looking at it, here are our discrete outcomes, and here are the probabilities for those discrete outcomes. And the first thing that we notice is that if we look at the sum of the probabilities, they actually add up to 1, because I've got 3 plus 6, that's 9, plus 2, that's 11, or 1.1 minus 1, so that is a 1. So they add up to 1, but I have a problem. This right here, this probability right here is not between 0 and 1. It is negative. So this is not a probability distribution, because of this right here. Now moving to the second one question to ask is, does it add up to 1? So there's 4 plus 3 is 7, 8, 9. Okay, so that adds up to 1. And then looking at our probabilities, are they all between 0 and 1? Yes, they are. Now my possible outcomes are not all positive, but that does not matter. They are all discrete. I can count them. There's one negative, but that has nothing to do with my probabilities. So this one, yes, is a probability distribution. Okay, moving to the third possible table, I can look right offhand and say this one will not be because of the negative. If I were to add them up, let's see here, there's 4, 7, 8, 9, 10. Doesn't even add up to, because that's actually 0.8. So that one doesn't add up at all. So that's not a probability distribution. Now on our fourth one, all my numbers are positive. So the next thing I have to do is make sure that they add up. So there's 10, 4, 5, 6, 7, 8, 9, and they add up to 1. So yes, that one is a probability distribution. Okay? So there's two things that you're looking for. Is there a negative or a number greater than 1? As well as, do my numbers add up to more than 1? So those are a couple of things that you're looking for when you're looking at probability distributions. Now, let's look at actually calculating probability distributions, or using the probability distributions. The number of customers in line at a supermarket express checkout counter is a random variable with the following probability distribution. So you have 0 customers, 1 customer, 2 customers, 3, 4, and 5. We want to know the probability that there are 2 customers in line at a time. Well, when we're looking for probability that there are 2 customers in line, we just look at probability of 2. And so that's 0.30. Now then, whoops. Let's get rid of that. And I want to look at probability that no more than 1. And I'm going to put this down here where we can see it as well. Okay, so there's no more than 1. And when we're talking about no more than 1, probability of no more than 1, that's going to include 0 or 1. And so that's the probability of 0 plus the probability of 1. So that's going to be both of these. So that's going to be 0.10 plus 0.25. So that's going to give me 0.35. The probability that no one is in line, that's just going to be the probability of 0, which was our 0.10. Now then, looking here, I'm going to look at the probability that at least 3 people are in line. Well, at least 3 means 3 or more. So that's 3, 4, and 5. So probability at least 3, that's going to be the probability of 3 plus the probability of 4 plus the probability of 5. So that's going to be 0.20 plus a 0.10 plus a 0.05. I add those up and I get the probability of at least 3 people in line is going to be 0.35. Now practice some with the probability distributions and let me know if you have any questions.